So now we're going to consider what's energy and what's power. Formally, energy can be defined as the ability of a body to do work. However, since we haven't looked at work yet, that's not particularly useful for our situation. Now, you probably know about lots of different types of energy. So kinetic energy is possessed by particles that are moving. If you lift an object up, you're giving it gravitational potential energy. If you change the temperature of a body, then you're supplying it with heat energy to change that temperature. So let's just stick with this non-formal understanding of energy for the moment. We'll be looking at work and energy more formally in the mechanics course. So the unit that is used to measure energy is the joule, and it has the symbol capital J. A really important law for physics is that in a closed system, energy is always conserved. Energy can be transferred from one body to another through various mechanisms. Waves are one way that we can carry energy away from one body and give it to another. So an example of this is if you consider the sun. It's giving off energy in the form of light waves. These travel through space and they can heat up things such as rocks on the surface of the earth. And so as the rock warms up, it's gaining energy, and it's gaining that energy from the sun, and the energy is transported through those waves. Now, power has a very special meaning in physics. Power is the rate of energy transfer. It can be calculated using the formula power is equal to the energy divided by the time. The unit for power is the watt, and this has the symbol capital W. So you've probably seen watts before. When you buy a light globe, it tells you how many watts it uses, and that tells you about how much energy it's going to use in a certain amount of time. So let's have a look at an example now where we calculate the amount of power that a light globe uses. Okay, so the question is, a light uses 60 watts of power. It is left on one evening for 3.0 hours. How much energy does it use? So to answer this problem, we're going to need to use our formula that the power is equal to the energy over time. Or we can write this as P is equal to E over T. Now what we've been asked to find is the energy. So let's rearrange this equation to make energy the subject. So we can write energy is equal to power times time. Okay, now we're told the power is 60 watts. So we can substitute that in, and now we need the time. So we're told that the time is 3 hours. Now the problem is that this 60 watts, that's the SI units for power, but hours is not the SI units for time. So we're going to need to convert this time into SI units. So we're going to need to convert the time into seconds. So we've got 3 hours, then in 3 hours there's 60 minutes, so we times that by 60, and now we're in minutes. But what we need is seconds, so we times it by 60 again because there's 60 seconds in a minute, and now we're into seconds. So now we can solve this on the calculator, and we end up with 648,000 joules. Okay, now this is a very big number, so we're probably better off representing it as kilojoules. So to get 2 kilojoules, we just divide by 1,000. So that's equal to 648 kilojoules. Now in this question, 3 hours is given to 2 significant figures. 60 watts, that's 1 or 2 significant figures, so we'll give it the benefit of the doubt and assume it's 2. So we should present our final answer to 2 significant figures. So we can write this as 650 kilojoules, and that's to 2 sig fig.